And we're live. It is Thursday, February 19th, 2015, 11 Pacific, and this is DB Hangouts. Today we're going to be talking about some learnings from operating TokuDB. So we have Jeremy Timley here, who wrote a pretty awesome blog post about it, and he's going to tell us a little more about it in person. Also talking about what's a good long query time. This is something Morgan had suggested. Since we had talked about InnoDB I/O capacity last week, this seems like another fun one to kind of continue on. Testing your backups, and MySQL 5.7 default suggestions, just kind of getting a follow-up on that with Morgan, who just left. Hopefully he comes back. But yeah, so let's go ahead and do a quick round of introductions. I'm Jeff Anderson. I'm a DBA at Box. You want to go next, Jeremy?
Jeremy Tinley, DBA at Etsy.
Okay, Mark?
I'm Mark Beef. I'm a development manager at Oracle.
Okay, Matt?
I'm Matt Lord. I'm a product manager in the MySQL group at Oracle.
And Shlomi?
I'm Shlomi. I'm an engineer at Booking.com.
And Morgan? If his computer's working. Might not be. Okay. Well.
Morgan is from Oracle.
Okay. All right. So without further ado, do you want to go ahead and take it away, Jeremy, and get rolling?
Sure. So we started an effort at Etsy. We had this search backend that we use. All of our search, whenever you search our application, your data goes in, or your query goes into a Solr cluster. From time to time, we need to rebuild that data from our Solr cluster. There's the incremental updating that happens on a periodic schedule. So when you add a new listing, the data gets funneled into there. That data store for that is backed by MySQL. So our previously we were using Percona Server 5.5, these platters. We were finding an InnoDB backing engine, and we were finding that when we were trying to do backfills of loading fresh data into the MySQL store, that we were hitting that as a bottleneck. So part of a re-architecture, this got switched out to be an SSD-backed system, and one of the other changes we wanted to make was to give TokuDB a try. TokuDB has some pretty insane compression rates and some pretty phenomenal insert speeds, and the workload that we put through this is pretty generally insert bound. So we started off with doing kind of a benchmark test of like a TEED write system to kind of get a real good comparison of where we were, and we found that we were going to, our 190 gigabyte InnoDB table space would go down to about 30 gig on Toku, which was going to be pretty impressive for us. And then our backfill of our insert process, we gained about 600% in speed improvement. So kind of wanting to ramp this up to full scale, we walked through the process of operationalizing. What this started with was we used Chef as our backing configuration management, so having to make necessary modifications to recipes. This will be our first Percona Server 5.6 deploy. This ended up launching with 5.6.19. We're now running 5.6.21-ish, somewhere around there. libjmalloc is pretty standard across our platform, so that's a requirement. Disabling transparent huge pages, I ranted about this a while ago. It doesn't go into Etsy syscontrol. It is, you have to do it live or modify your RC local, which is kind of frustrating if you do anything else with your RC local trying to do this in this one recipe. So we actually configure Chef for us, or MySQL for us not to start MySQL on boot. We just wait for Chef to run its first time, which will do disabling transparent huge pages and start up the server for us. Then installing the plugins. So when we started, we were doing basically just the big blob of insert load plugins. The later versions of Percona Server now have a really cool script that you can run that checks that you've got JMalloc and transparent huge pages disabled and your plugins are loaded. Actually made the process a little bit easier, but effectively you're just doing a bunch of load plugins. So once we got kind of our production cluster up and running, the next one was configuration. Configuration really came down to just a couple of variables. The defaults for Toku out of the box are extremely sane. There's one got you that we found defaulting our normal conf file, we allocate about 80% to InnoDB. Toku will use 50% for its cache size, and it wants the other 50% for Linux disk cache, so that your all the reads and writes that go to it, remember, right, it's compressed data and uncompressed compressed data is your OS file cache. Uncompressed data is kept in memory. So we were over-allocated. Kind of silly, but just modifying it down to like 5% InnoDB, since this will be a purely Toku engine. Making that modification kept us from running out of memory, which was pretty useful. The other bit was looking at the TokuDB data directory. When you load all your files, everything gets put in data dir with a lot of prefixes. So you've got like your database name underscore table name underscore type with a hash .tokudb. So that's a little different for people who are familiar with like the InnoDB styles of like file per table, where you've got your database name in a directory, and then inside of there you've got your form file and your IBD files. There is an open bug, thanks to Shlomi, where we want to see if those files can get moved out of there. I'm just a little OCD on what I want to see inside of my data directory. Keeping all those files around was a little distracting for trying to find what I'm looking for. So once configuration was kind of handled and we got things running stable, we took a look at monitoring. Monitoring is basically the same for us. There's very little that we need to modify. We really care about, is MySQL up, is replication working, are we reaching max threads? You know, for kind of a big monitoring point of view, that's really all we care about. And since all that stuff is handled at the MySQL level versus the engine level, monitoring Toku is pretty much the same. We probably at some point, for graphing purposes, will do a kind of an extension and start pulling in a lot of the data that we get from show engine TokuDB status, which is very nicely formatted compared to InnoDB status. If anybody's tried to parse InnoDB status, then kind of pulled your hair out for a little while parsing these regular expressions and what changed in this version, and where do I find history list length now. I know that there's been a lot of great work going from like 5.5 to 5.6 and even beyond of trying to get a lot of that data put into show global status. The Toku display is basically exactly the same as a show global status. It's a bunch of key value pairs. They're nicely prefixed, which was really cool to be able to see. So like checkpointing information, fractal tree, memory, they're all prefixed so you can find exactly what you're looking for, kind of alphabetically grouped together. There were a bunch of information schema tables, a lot of things for lock visualization, nothing that we've had to look at in depth yet. We've just made this production in the last week or two, so and our workload doesn't end up generating a lot of locking issues. Global status has some good values. If I remember right, TokuDB status has like 301 values. Global status was like 60 or 70. There were a lot of metrics that you can gather, getting pretty nitty-gritty. What I have not really gotten into is determining what we actually would care about from a monitoring standpoint, though. Not having a good sense of how the engine differs from InnoDB, or what our workload is going to generate and what we care about to see contention points, that's been a lacking point so far. Hopefully I can come back and, once we get a better idea of that, get a real good viewpoint. After monitoring, backups. We use Percona Extra Backup, not an option for TokuDB. The way that Extra Backup works by reading all of your changes and storing them and then being able to reapply them just doesn't work in the Toku world. So we grabbed MyLVM Backup and used that as a base to work with to do LVM snapshots. I think these are 4.4 terabyte volumes, and so we just threw 1% at it, which seemed even more than enough for our current usage. I did do my own modification to it. The fun part about LVM, you want to store your snapshots in another location, not your snapshot volume, or you run out of snapshot space real fast. I actually just modified it to do an SSH copy of the file over to our backup server with compression on the fly, rather than trying to write compression locally and then do like an rsync later. The rsync method worked pretty well. I just didn't like having all the different files. I wanted to have it all just tarred up and compressed into one file. So that was actually pretty straightforward. Being able to restore those has worked very successfully, just restoring it like you would restore any other LVM backup. So kind of the results, as I mentioned before, 190 gig DB table space that I believe was using the 8K page compression went down to 30 gig on Toku. We did see a slight increase in the user CPU just because we're doing a lot more compression. That compression rate, I think, was the highest level of compression that you could enable. We weren't CPU bound on this. If anything, we'd find ourselves more disk bound on our general hardware platforms. And then, like I said, we got a 6x performance on our backfills, and we moved our bottleneck away from this database and actually into the workers that are trying to do the backfills. So all in all, this was a pretty successful win for us. I think that we need to gain some more exposure with 5.6 in general and Toku before we would consider it in another environment. But I think from our point of view, this is a good step forward.
Okay. Thanks for the very detailed overview and walkthrough. And I think I got most of that captured. So a lot of this stuff is already in your blog post, is that right?
It is. You can just link to it.
Okay, cool. Yeah, I will put a link up to that. And it's actually interesting. So did you have LVM on this machine before you started using TokuDB, or were you actually just doing extra backup for everything and no LVM?
So in our typical hardware footprints, we do not use LVM at all. If we have a couple of newer boxes where we're doing half disks on split controllers. So we use LVM to stripe the volume together and then just stripe 2 for writing across both of them. So we have implemented it. Earlier benchmarks that I did on one of my previous blog posts showed that LVM added a pretty nominal, like it was very, very small amount of overhead. So there really wasn't much concern, but actually configuring snapshot spaces was new to our environment. LVM itself as a snapshot method, our typical workloads don't allow us to do a flush table with readlock without seeing some pretty major issues, number of queries that we take in our environments. This one is a pretty low, it's very insert intensive, but we're taking a feed of all of the modified data that hits our user shards, and then we're replicating that into this environment to basically be funneled into Solar. There's some work that can be done on repping out things like whether you want to search for red and maybe you want to include other synonyms for red that help generate better search results. But in general, we're strongly an insert workload on this. That's why Toku was, I think, a pretty good fit for us.
Okay.
TokuTech have a hot backup tool. I vaguely remember they do. I don't know for sure, but I thought they had a hot backup tool as well.
They do. They have a frequently asked questions page on their website, listed out basically all the backup options that you have of cold tar or LVM or their hot backup. Their hot backup comes as part of an enterprise solution. Since this was a pretty low utilization and low footprint, and to be perfectly honest, it wasn't the most critical environment that we have. We just didn't want to go down the enterprise route.
Okay.
As I recall, their backup tool is also if I'm not mistaken, it's also snapshot-like, so it's simulating this snapshot by some way. I remember reading about it in the past, and that was my understanding. But like Jeremy says, LVM works just fine, and recovery is just fine with any kind of snapshot. So Jeremy, what's your typical workload on the master? I mean, concurrency-wise, contention.
It's actually pretty low. It's going to be strongly insert, so I'd say maybe 80% insert, and then that data just gets a select read off of it. So we're keeping track of all the changes that happen to listings or people make any modifications to their shops. Those things. This one is explicitly for listings, and we'll start migrating more search options into this infrastructure as we become very confident with how how it's working as a backing store. But right now it's going to be strongly insert and then reading selects as we pull data from this location and rebuild it into Solr.
Yeah, I guess that was going to be one of my other questions as well, because you mentioned that you've got a lot of monitoring that's there by default, but one of the other questions I was going to have, and you probably don't have the problem though, is debuggability, right? So how you trace transaction locking, deadlocks, all of those kind of things with TokuTek versus the way that you do it with InnoDB and show engine InnoDB status and the IS tables and
right.
Kind of stuff.
You're absolutely right. From what I've read, there is a lot of information being exposed. The information schema tables have a locking set of locking tables, so you're able to go in and view locks and for transactions. They have actually a post on their troubleshooting section about viewing transactions, locks, lock weights for how you determine how you are hitting your locking issues. But for our workload that we've generated at it, we're not pushing this box at all. We can do full reindexes of like 30 million something listings in a fraction of it. I think it's 4 minutes now. And we just don't ever we don't push this at all. We don't move any of the needles anywhere. It might just be because we've kind of overspec'd the box. It's like 4.4 terabyte SSD, RAID 6, 256 gig of RAM, probably something like 40 hyper-threaded cores. I mean, we probably threw too much hardware at it for what we were doing. We'll get probably closer to that as we start moving a lot of other things over from search into it. Conversations that happen on our site, anything else that you want to search, past transactions, that kind of stuff. When we start moving a lot of that data over, I think we'll start to see us move things around a little bit as we do reindexes. I hope to revisit it. I hope we run into problems. I'd like to actually find something rather. Sometimes it can be kind of boring actually just turning it on and everything just works out of the box. Helpful for your day, but not quite as interesting from an operational standpoint. One other element I want to talk about, kind of as a piggyback on that, since this was our first 5.6, I got a chance to play with multi-threaded slaves, which was really awesome. We were hitting our reindex, I guess when we did the initial load of all of our data, we started seeing replication lag. We were processing ridiculous amounts of inserts a second, and that single thread just couldn't keep up. So I wrote a sister blog post to it about how you actually go about enabling multi-threaded slave, and it's pretty awesome. I mean, that coordinator thread is just was doing a great job of picking up and funneling everything to workers. We actually explicitly architected for the possibility, so all of our listings are sharded across, I think it's 64, 128-ish, something like that, databases spread across multiple machines. I think we have 16 or 24 databases per machine. So we actually are pretty easily set up to take advantage of multi-threaded. I'm looking forward to 5.6 and seeing how it handles the group commit portions of multi-threaded slaves, being able to not actually worry about it being schema independent and being able to, sorry, 5.7, thank you. 5.7 being able to not see it be schema dependent and being able to actually just blast through everything. I'm actually looking for more information of how the coordinator thread determines how many worker threads it can populate. Is it if it's based on the sequence of how many of your events? So if I take shards 1 through 24 and I say if I've got multiple events from shard 1 in a row, will it only populate one worker, like a first in first out array, or will it actually skip up to the next one in the event list and try to parse shard 2 if that's 4 or 5 queries down the line while that first one for the shard's running?
So if I remember right, because I'm not the product manager for replication specifically, that's one of the few server side things that Andrew Morgan deals with. But if I remember correctly, it's basically disjointed sets. So most of that's taken. So group commit is also improved in 5.7, and so basically you can take an entire group commit, and it should have, and that can be thought of as a, kind of an independent set that can be executed. And I'm not sure how it actually does the underlying work to determine, okay, I've got, say I've got 8 parallel worker threads, and how it determines that a given set is independent and non-conflicting, I'm not sure. I can try and find out. I've only been paying attention to the kind of user visible side of it, rather than what's happening underneath on the code side. So
no worries. What I noticed was we were doing 1,000. The single thread of replication was doing 1,000 inserts a second. Our average traffic coming through was about 1,200. So we were just pushing ourselves behind. 2 worker threads would have actually been sufficient to keep us. But I was able to actually ramp up from 1, 2, 4, 8, and 16. And the stepping was pretty crazy. We ended up with 3,000 inserts a second to clear the backlog. And once we chewed through everything, we actually ended up, because we weren't doing the backfill anymore, we turned it back off. A nice way for us to do that. When I was going up to like 8 and 16, I was noticing that a lot of the worker threads were actually sitting pretty idle. And I was wondering if it worked very, very much on like the more schemas that you have, the better, or the more disparate the inserts are across the schemas, the better the worker threads are able to take care of it, or if it was more like we're going to just take as many as we can fill up on the worker threads and keep track of the low watermark positions, and we'll take care of everything eventually, but maybe it only reads the first 8. If you have 8 worker threads, the next 8 queries, and then tries to divvy them up as best as possible, and that's why I had idles. It was kind of just a curiosity.
Did you encounter any other issues or kind of buggy behavior when you turned on multi-thread slave? And do you want to talk about that?
With some sort of knowledge. I did. Restarting Percona server would generate a 1755 error, which was kind of unintuitive. What I found was the workaround for it was basically just set concurrent workers back to 0. I tried to reproduce it in community. Same minor revision. I think it was .21. I think .22 is latest, and was not able to reproduce it in community. I think I kind of traced it back to some additions that they made in Percona server. It was frustrating, but not a stopper, and that's why actually for us we're keeping it at 0. And then just manually going in and turning it up higher so that we're able to catch up if we do see bursty bits. The workaround, totally viable, just kind of irritating.
I'm going to put a link in the chat just so you can see exactly how it's done. Has some more details, but it uses kind of a combination of role-based binary logging, combined with a group commit on the master, and then it adds a logical clock or counter, so then it knows it can execute. Each worker can go off and execute everything that's associated with this particular group commit in parallel. But for more details, let me put this link up here. But you didn't get a chance to try 5.7, right? You were just aware of it.
Yeah, what I think I remember Mark mentioning that 5.7 is going to get rid of the need for 1 worker per schema type approach by having a more improved group commit, and that actually seems like it would be an even bigger boost for replication just by being able to use better group committing.
Yep, and you can add the way the group commit's done has been improved a bit too, so you can typically get a bigger window, so bigger groups as well. So yeah, if you ever do get a chance to test it out, I'd love to get your feedback on it, see how well it worked for you. I had one question. So I think we all know what TokuDB's sweet spot is, and that's, or at least I think I do, and those 2 things that always stick out to me are just kind of the insert speed, and particularly for like bulk inserts, and compression ratios. I'm just wondering if you had noticed any weak spots, because nothing's perfect, obviously, everything has its pros and cons. I'm not really sure what the cons are. I'm assuming that it has some. Like, I guess I kind of always assumed that it was a bit weaker when it came to point selects and range queries and things like that, but I haven't ever really seen any benchmarks that I can remember or anything.
Not yet. It's still pretty new. I'm hoping, like I said earlier, that we find some sort of challenges that we have to dig into so that we can learn a little bit more. It's we did leverage it because of compression and inserts, which is the bulk of what we want to do with this. So yeah, I think we'll be able to, as we begin to shift more search stores over to using TokuDB, I think we'll get a better idea if we start to see some more pain points on it.
So that was actually something else I was curious about, Jeremy, was how is this this actual architecture you have set up? So I mean, you have events coming from your other parts of your environment, and ultimately, are you just generating an insert like for a simple search string, and then this is kind of bulk selected out of to load Solr, or like what's the kind of pattern for this system?
That's one I probably would love to come back and talk about as I get more familiar with it. I was actually just starting to learn about this architecture, so I'll give as much as I can, and then hopefully I can come back and talk about it a little more. So if you go in and you create a new shop listing, that listing is not available right away. As I understand it, Solr has some penalties around trying to get like sort of the incremental updates, that it handles those better if you do sort of batch updates with the way that it writes data. So at least that's what the team tells me. So from from the database side, I'm basically my data store is going to keep a denormalized form of what a listing looks like, and then they're able to then pull that data in bulk as a large select and then rebuild what they're looking for. There are algorithm changes that happen behind the scenes that require sort of the reindex of a lot of information. So being able to pull all of that in one location, very concise, in a pretty speedy manner has been pretty helpful for them. The end-to-end looks like you create a new listing, you modify your listing, that gets queued up as an update. One of the nodes will go in and pull that update from the data store, from the user's shard data. That gets stored in this denormalized form over here on the search backing store, the MySQL store. And then on a periodic process, when they go in and reindex or rebuild data, either whether it's the incrementals or they're doing full reindexes, those happen from selects off of that data store. We've got a pretty wide amount of shards, so trying to pull up all that user data sort of in real time from lots of different nodes and then aggregate it together and do all that. It made more sense to have one data store that's constantly being updated, and then one select that happens kind of on a cron of like maybe 5 or 7 minutes, and then pulls all those changes, shows them into Solr, and then that process just keeps repeating.
Got it. And so is the TokuDB setup that you have now as your aggregate store, is there any like periodic cleanup or purging of the data in there, or is it meant to just kind of grow incrementally?
It grows incrementally. To get more into it, I need to go back to the team and get more detail.
Okay. Yeah, I was just curious because I mean, we run Solr as well for our search stuff, and yeah, we every 5 minutes or so there's a cron that kicks off a whole chunk of workers, and they connect to all parts of the environment to grab metadata about content that we're storing, and ultimately go back and incrementally index that, and then every couple weeks or so a full index gets kicked off, which does a much longer walk, obviously.
Right. Yeah, we do the reindexes, I think, fairly frequently for algorithm changes or better search things that we've learned through data analytics. There's whole teams that we have that just manage through what those algorithms are and try to come up with better search results for what you're looking for. And so the backing side of that one from the application is really just an A/B side. And so searches are always happening from one side. You do a full reindex on your B side, and then you flip all your stuff over to look at the new one. And if things look good, you stay there. If not, you can always fall back. So we always keep sort of that A/B notion and always having a dark side that you can reindex or play with, so you're never touching prod until you're ready to flip over to it.
Okay. So another question I had about TokuDB, and you might not have gotten to do this part, but schema changes.
You're right. We've not done any schema changes. The schemas we came in with were pretty easy, and everything since then has all been creates. that stuff doesn't change too much for us. So I don't have any practical experience yet. Sorry.
Okay. Yeah, I mean, I just remember Tim talking about how they had the message buffer kind of structure. Oh, Shlomi, do you have?
Yeah, so I have first to answer your question, then to answer Matt's question. So we've also experimented back at Albrain with TokuDB. We used it on in OLAP servers, so it's mostly single-threaded loading of data. We did use the online schema changes, and they work perfectly well. We added indexes, we added columns, and the tables were non-blocking. So the query itself, except for the thread that was initiating the query, that thread was blocking. It was supposedly not meant to be blocking as well, but doesn't matter. The query that was issuing the online outer table was blocking itself, but otherwise inserts, no problem, changes, deletes, anything, it's no problem. So it's rather cool. You're adding a column, and you can right away start using that column, right? Even before it ends. So that's pretty awesome. And with regard to Matt's question, so the thing we noticed about TokuDB is more load than we used to have with InnoDB. So like concurrent load data, concurrent inputs from Hadoop, for example, we have multiple scoop jobs running and loading into a table, a partition table. They would have loaded into different partitions or into the same partition, but never to the same set of rows, and yet there were locks. So one of them would completely hang until the other finished. We had this, we had this repeating over and over, and the last version of TokuDB that we tested was 7.1.6, I believe. So I don't know, whether this was solved afterwards, because there's quite a few events. Anyway, that's what we noticed.
Okay, cool. So any other questions or comments folks have about TokuDB and just operational use experience? Okay, I'll take that as a no. All right. Well, I guess we can move on to talking about long query time. The long _query_time config option. Morgan is smiling. I know why he asked this question. Oh, it has to be 0?
Yeah. You always set it to 0.
But that'll blow up your disk, right?
Sure. That's a system admin problem, though, right?
So does someone want to do a quick explanation of what it is and how you should set it, maybe? I'm happy to. I just figured someone else might want to talk about it.
Set it to 1. 1 is the magic number. That's my personal opinion.
Why is 1 the magic number?
Because setting it above, 1 second is something that is humanly tolerable in terms of maybe, you have to draw the line somewhere, right? But I don't know. It's that kind of threshold that if you set it to 3 or 5 seconds, then you're bound to have like 5 times more slow queries than you would if you were to eradicate any query that appears in the slow query log. And if you're doing your job as a DBA and daily removing and optimizing all those queries, what I've seen is that if you go above 1, you're still stuck with a whole lot of slow queries if your system is like shaky. It sounds like a magic number, but it really makes a lot of sense. If you eliminate anything running above 1 second, you're way above 99% of your slow queries. I'm just throwing around magic numbers, right? But they always worked for me. This number works for me.
Yeah, I would say.
And 1 second, 1 second is something that you may be willing to actually wait on interactive shell or whatever. So it's something that's visible but not too long. I don't know. Works.
I would say 500 milliseconds these days is probably getting to be considered slow. I think Morgan, I thought Morgan would probably want to talk about it, but I don't know. It sounds like he's not in a very good position to talk. But
I wanted to hear everyone else talk. I don't know if you can hear me okay. I do think even one's quite slow.
Well, so that's the interesting thing, right? Was my experience at the long query time. You know, when you first hear about it, you're like, okay, this is for the slow query log file. You want to set the long query time, or oh man, I already forgot the name of the variable. The long query time variable to whatever that threshold is for you to be like the slow queries. But I mean, for us here, and that's another question I'll ask in a second. But for us here, we turn on the slow query log for a couple seconds, multiple times in the day, and capture probably about 1% of total traffic. But we set long query time to 0 because we want everything during that window. And I mean, for us, you know, we don't have a lot of, statistically, we don't have a lot of queries that run more than a second or 500 milliseconds. Like most queries finish in, you know, a couple milliseconds, not even 100. You know, if they're optimized well. And I think for us, more of our problem's been we don't have queries that run for a long time. We just have such a high volume of a specific type of query that runs for a short time. And as the data set grows, or like, you know, indexing changes, things get a little weird at that point, and it's more about the aggregate view. However, General Log was another location where you can get all that information, and so that's, I guess, what I'm more curious about. In addition, is, you know, when folks who've set long query time to 1 second or something, you know, are you doing that to look for genuinely just long queries, and then you do something else to track total, you know, aggregate query performance?
well, I think, well, in my opinion, things like the MySQL Enterprise Monitor or any tool that you have that can build on top of like the performance schema data is even more useful, because in my experience, like with a slow query log, like you said, your queries may be fast, but that doesn't mean that they're not going to be problematic at a certain scale. Like maybe your query is fast, but it's examining 100 rows when it could just examine 1. And so you don't necessarily realize that until you hit a certain scale and a certain amount of concurrency and contention, that things like that then become problems, and you could have dealt with it long before. So that's kind of where, in slow query log, obviously is focused on the amount of time it spends. One, you can get it kind of raw information, but then it's certainly not easy, because you can use, like, what is it, MySQL dump slow to kind of get some aggregate statistics. Then you can go back and try and find individual queries, but it's a manual, somewhat tedious process. So any kind of tool like MySQL Enterprise Monitor just being an example of one that uses the performance schema data to give you, like, you know, there are many other indicators the query is problematic. One, of course, obviously, is that it takes a long time to run, but like you said, in your case, you may not have anything that really takes a long time to run. But you want to see, is it, you know, what's creating temp table on disk, for example, you know, what's examining more than 5 rows, just to throw a number out there, and things like that, that are indicators of potentially problematic queries, or queries that could be improved, let's say. And that's kind of what you really want. Obviously, you want to start with the most problematic, but you're looking for stuff that can be improved. And whether or not it's slow doesn't necessarily, you know, it's not the only indicator of whether something can be improved or not. So that's for me, that's kind of the limitation of the slow query log. One is just a lot of slows things down generally. As you saw, you only enable it briefly. It does a lot of disk I/O, creates a lot of disk space, and then working with it is a little bit tedious and manual as well.
So Vivid Cortex, which is a commercial one, takes a different. You just speed up, so it index all your on your master slaves, whatever, and measures them all, and it does on a second basis, and nice algorithm that, you know, if you trust them, they do the calculation of how much each query consumes the CPU or the disk I/O on a per query basis. So breakdown of whatever query you're issuing repeatedly on your days, how much I/O and how much CPU utilize it. So it's pretty nice to just turn it on, and those are your top 10 queries, and that's what you're doing. Either it's a 1 row or 10 rows or 100 rows, you get the answer by just measuring how much it serves. So that's a pretty cool approach.
Yeah, and it also does packet
other,
sniffing, which is pretty interesting. I haven't played with it yet, but I kind of follow it, and it looks pretty interesting.
Yeah. So the approach is very different because it doesn't just intercept. Like, you don't need to turn on performance schema, or you don't need to log every possible query in some log, and that's nice. The breakdown of the CPU and I/O per query is something new, very different from other conservative approaches.
Yeah, it's interesting. I'm assuming it does, maybe it grabs a time slice and compares CPU usage during this brief time window that the query executed, and yeah, it's cool. I would like to actually try it out sometime. I've been following their blog and everything, but I haven't actually tried to use it against a production MySQL instance or anything, or even a QA or test instance.
Yeah. Yes, we kind of at Outbrain, and it was just like you get the first breakdown, you just pop up, and at least the top 10 queries made perfect sense to me, and it just seemed to be doing right. So these were familiar to me. It seemed, and it was putting measurements into this, so it was very nice. Yeah.
Yeah,
it's a speech. I'm not an interested party.
But so to your point, Matt, about the slow query log can get a little unmanageable and large and all this other stuff. I mean, for us, it's we have a cron job. It turns it on and off multiple times a day. Kicks off PT Query Digest against it, and has it using the options of PT Query Digest to just dump it into a central store. And I mean, ultimately, then we use Anemometer, our little UI, to just look at all that stuff, and that's how we get it. The problems with that, though, and I mean, this isn't only with slow query log. This is like any monitoring is. If there's some sort of event that happens that slows the whole server down and just dramatically increases runtime of everything going through it, and so queries that are normally have a nice run, if your server has some really nasty problem, you get this massive spike on everything. And then it's a question of, whose fault is it? Was there one query that actually pushed everything over that caused everyone to have a bad recording? And I'm actually curious.
Well, the other thing about that as well is if you're only turning on the slow query log every now and then, how do you catch it as well, right? The only way that you catch it is somebody complaining somewhere down the line and you having to go back and try and trace it. But this is why I think performance schema being turned on by default in 5.6 and then just using the slow query log as a proper slow query log rather than a 0-second capture everything is the right way to do it, because you get to capture those exceptions even in the aggregate stats, and you can do deltas and all of that kind of stuff. I know Gavin's done that with Anemometer, right, with performance schema as well.
Yeah, there's a 5.6 performance schema patch in there, I think, that works with it. But I mean, we don't have 5.6 deployed everywhere yet, so we still have our slow query log cron job running out in the wild until everything's upgraded.
Yeah.
But yeah, Jeremy, I mean, do you want to talk about what you guys are doing? How you, I guess, analyze this kind of stuff, or?
No.
Okay, so you don't. Okay, there's no problem.
So we track a lot of stuff. I think we actually had a Hangops a little while ago where we talked about what we monitor. I think for us, we track sort of a lot of the InnoDB counters and like queries per second and inserts, selects, updates, deletes, com counters, and that kind of stuff. And then we just kind of try to look at it. Slow query bits, we track that. We have like a slow query velocity type thing. So if we see a large burst of them, that'll actually hit a Nagios alert. Some of our non exploits are all based on data that we store in Ganglia. So trying to get a good gauge of how we would clean up those types of things. Actually, our ORM has some wrappers around when you make queries so that if it exceeds a certain time, it logs it to the logs, and then all that data hits Logstash and Elasticsearch, and you can go query the stuff. So we do have devs that will go in periodically and review that stuff and say, oh, we should probably look at how we can fix this. I just had one on Monday or Tuesday that we just looked at where making a modification to remove one of the clauses for that would help. We don't, from a DBA point of view, I tend to view us more as system admin-y people who work a lot with more of the systems rather than looking at specific queries. So for us, I think the devs do a lot more of that work. We would track it, we log it, we let people go in and fix them, but we don't actively, as a DBA, I don't go actively chase down people to go solve some of those. If something bad hits production from a push, everybody notices it on the graphs anyway, and it gets fixed right away. It's usually those really rare ones. I mean, everybody's watching graphs here, so I think especially whenever you're pushing code. So I think those things get noticed pretty quickly.
Okay. And just out of curiosity, Shalomi, like, is Booking.com doing anything special around that, or?
No, using the conventional method. So yeah. Sorry.
Okay. Well, I mean, do folks have anything else they want to say about long query time as a variable, or Morgan, did you have any thoughts around it that you wanted to say?
Sure. At the moment, so I'll be quick. We think it's too long as well, so we're proposing to lower it by default in MySQL 5.7. And it's kind of hot off the press. I haven't logged it yet, but we had the discussion just yesterday internally. And our compromise is we're going to pick 2 seconds, actually. So 2 seconds seems like a good threshold. It's the same as what New Relic would be for logging an actual complete page of if that transaction took too long. So, others are in that number. I did some competitive analysis. MongoDB is about 100 milliseconds for what they consider slow. So that's interesting as well. But certainly interesting to hear a lot of people say 1 second. I think that's good. It's healthy that people are choosing much smaller numbers. You're looking for a low-hanging fruit, and sometimes you find that in the really long stuff, but sometimes you find that in the slightly quicker stuff too. So 10 seconds is just too long, in my opinion.
So actually, something that I was just reminded of, and we might have talked about this previously, but is there any idea or notion of having a way to do basically a long transaction log? And mostly because this has been a problem, at least in the environment I'm working in, where queries, sure, some queries can run long or short, but it's more problematic when you have a transaction that is running for minutes, hours sometimes, and then ultimately it's making thousands or hundreds of thousands of modifications. And the only way you can really track that is you can look at the InnoDB history list length to see how many dirty pages are being tracked by the server if you're running the InnoDB storage engine, and then show engine InnoDB status is kind of like your next best bet to see everything about a transaction that's running, some of the lock structures, and then querying stuff out of information schema. I'm not sure if this is much of a problem for other people. I'm just curious if any thought around doing some sort of long transaction log, long transaction time.
So I think the best way actually is using the InnoDB transaction table, the InnoDB underscore TRX.
My connection kind of dropped. Oh, sorry.
I mean, that's what I'd use for it if I was going to create a log and just poll that pretty regularly.
Yeah, and so we have a metric or a collector that does that already, so we can track number, but yeah, I mean, I guess that's kind of the information. I was just wondering is there value in doing something more involved, maybe? I don't know.
I've had similar questions. I've had similar questions because I want to do and we've talked about this before, the long-running transaction killer, rather than something like PT kill, but not just on statements, but on transactions too. with the idea being that it would capture, kill, and log all of those as one whole unit, essentially. And it would work, I mean, the way I've imagined it is working it off the InnoDB transaction table and constantly polling that with an event, trying to find those transactions, killing them, logging them off, and trying to get more data on them. But I guess the interesting thing from my perspective is what you'd want to see, ideally what you'd want to see and log along with that.
Yeah, no, sorry, I couldn't hit the unmute button, but yeah, that's actually the interesting question, right? And that's the thing is, if I see a transaction in our system, maybe it's running, it has 100,000 dirty changes, it's been running for a couple minutes, and it's like high velocity, just changing a lot of data, and making a decision to just automatically kill that or log that information. Like, that's another state of, like, I actually don't know. I mean, because dumping, at the very least, you could dump stuff about, like, you know, here are the tables it touched, but there could be a lot of those. You know, here's the number of locks it had. Again, there could be a lot of those if you dump the full state of all the locks. And then the even more involved or super verbose would be tracking every single query that goes through. And that's the thing is, for us, you know, when we have this running, with our system, what we're doing is maybe we'll run a TCP dump for a little bit against the ephemeral, or yeah, the ephemeral port that it's coming in over, or the source host, to figure out what queries it's sending. And if we can grab one of those queries, then we can get a stack trace, one of our code stack traces off the back of the query, off of a comment. But yeah, that's why I'm actually not sure. I was just kind of curious if other folks had thought about this, if it was something on their minds or a problem for them. And it sounds like, yeah, go ahead.
No, for sure, because part of the issue is with InnoDB, you have those long-running transactions, and so you have to maintain that read view, which can block purges, and you get that long history list, and that can be problematic. So I think that's, you may have other reasons to be concerned about it, but I think that's one that I think in general for MySQL makes it a concern. And so we've kind of talked about having a transaction timeout that's been floated around, and that could happen in an upcoming release. And if you want to, another thing I'll note is we just, in the next release of 5.7, we'll have the transaction instrumentation and performance schema will be enabled by default. So that's another, in 5.7 you can use the transaction, events transactions current to see what the current transactions are, and to try and track anyone that's been running for a long time. And then you can look at the history, transactions history table if you want to kind of get information about transactions that have been committed or rolled or ended, I should say, but they were around for a long time. So that's another option moving forward. But I think the general issue, yes, or the short answer is yes. We have thought of it as an issue and something that we should look into. So on the monitoring side, in 5.7, you have the new consumers that are enabled by default for transactions, but automatically timing them out at a certain point, that's another thing. I don't know if that would be of interest to you. So like, you know how we have the wait timeout, which will just kill an entire action. Also now in 5.7 we have the query timeout, where you can time out read queries. So you can say, you know, query time, statement timeout at 10 seconds. Would you be interested in a transaction timeout? So let's say a transaction will automatically be essentially killed, and an implicit rollback essentially will be done at 60 seconds or 10 minutes or whatever the case is.
I can definitely see value in that, just because we've effectively built tools in cron jobs that do this kind of work, where they look at the history list, they check amount of lock contention happening on a given set of records, and make a decision to kill the source responsible for that. So having a configuration of the server would be much nicer, and also a way, status counter tied to it, or something to make it so you can watch for that and detect if it's happening a lot.
Okay.
But yeah, so, and actually, we've got about 5 minutes up, but I'm curious about some of these new instruments then, and I imagine, Mark, you're probably like knee-deep in doing something to leverage them with Enterprise Monitor. but just like what kind of information can you actually get with these new transaction instruments and performance schema?
So with the transaction instruments, you can get the type of transaction it is, whether it was auto commit or not. So isolation level, whether it was auto commit, who did it, how long it lasted for. There's a few other things, but those are the really interesting ones. And then because of the way the performance schema works and links together every event down from a transaction, essentially through statements or procedures down through all the different wait events, you can also link it to the statements that actually ran as part of that transaction as well. So not only are we turning on the events transactions history consumer that Matt mentioned, we're also turning on the events statements history table as well at the same time, which is essentially the last 10 statements per thread, connected thread on the system as well. So you can get the last 10 transactions, and then for the last one, essentially, it depends how many statements on average you run in a transaction, I guess. You can link down to the statements that actually are part of the currently executing transaction as well. So you will be able to, if you're going to log something like a long-running transaction and it's the currently running one, you'll be able to see at least the last 10 statements that have run as part of that transaction as well by default. And that has all of the rest of the statement instrumentation. So how many rows it's affected per statement, whether it did temporary tables, whether it's doing a full table scan, all of those kind of statistics are in there too. So that's kind of why I asked the level of depth that you'd want to have tracked in those things, because we can get down to all of that. We can link through to all of the different statements that happened and all of those things.
That actually sounds like it would capture everything, and I guess the only other open question mark would be being able to configure how much statement history to store, which I think that's probably something you can set in performance.
You can configure that as well on a per thread basis too.
Perfect. So yeah, that actually might even be the best thing, is if I can already see it. Like if you have a transaction that's been running for 20 minutes or something ridiculous, you can go into the server and turn on statement logging for that transaction specifically, and increase the statement backlog so that you keep consuming them or something. That sounds very cool. Okay, well, so we got about 3 minutes left, so I think we should start wrapping up. Did folks have any other thoughts around long query time, all this transaction discussion we just did? Anything else before we call it a day? Okay, well, we'll do a call for topics then, since we are at the end. So what kind of stuff do you folks want to talk about next time?
I'd love to hear more about anybody's experience with global transaction IDs, getting them set up, turned on, problems they run into. They seem to be the solution to solve a lot of challenges with setting up new servers, but I don't see them being adopted very highly yet. I'm curious on people's input there.
Can someone from Oracle talk about the binlog group commit? Like, do a 20-minute, 30 minutes maybe introduction to that. That's a kind of Galera-like multi-master solution, if I understand correctly.
Group replication.
Yeah, sorry, group replication. Thanks. Yeah.
Well, I can't promise anything because it wouldn't be me if you want an expert. I mean, I could pretend to be an expert. I guess I could read up, but I'll ask if Andrew or Luis would be willing to join and talk about it. They're the real well, it's Luis in particular. He's the real expert, so I can ask him. And if we can't get anybody else,
presenting that.
Yeah. Or there's a couple other people that might be able to join too that have worked on it. So I'll ask, and I think we can probably get somebody to discuss it.
Cool. All right. Any other topics? Oh, that must be a name that you just put in there, Mark. Okay.
Yeah.
All right. Well, okay. So hear more about GTID and people's experience with it. Hopefully we can get some other folks who have messed around with it, turned it on, especially since I think it was a week or two ago, Percona had put up a blog about their new server version, being able to do online migration with GTID, so you don't have to take everything down. So that might be interesting to talk about as well if anyone's done that yet. And then we have some of the other stuff we didn't get to today. So talking about backup testing, this was something Daniel had requested. So maybe we can get to that next time. And 5.7 defaults, kind of been out. So it might be interesting to see if we have some kind of update on that. Morgan, if everything's kind of settled, what we're looking at, and if they're still open for feedback.
Well, I think we're always considering feedback. We think should change. We pick on the time frame that it makes sense. I'll have another post going out the next week with some other changes that we're proposing. So there'll be an opportunity to discuss that next time for sure.
Okay, perfect. Alrighty. Well, with that, thanks very much for your time today, everyone. Thanks for participating, and we'll see y'all in 2 weeks.
Thanks, guys. Have a good one.
Hello.